So my presentation will be about one technical aspect of FLNGs, is the containment system, the storage tanks that you can use for your floating units, and in particular the membrane ones, which are designed by GTT. So my presentation will be around 4 main points, some examples of integration of our membrane systems on board FSRUs and LNG FPSOs, some design options that we offer in terms of technical solutions to cope with offshore production constraints, some words about construction of the unit, and then another point about maintenance. And just first, for the one who don't know GTT, just few words about my company. We are an engineering company, a French engineering company. We are based close to Paris. Around 50 years of experience in the design of cargo containment systems of LNG called membrane. We have 3 shareholders: GDF Suez, Total, and an American investment fund. We are a relatively small company. We are around 300, a little bit more, and all working on new technologies and projects linked to our containment systems. We have several technologies. One for, on one side, for floating things, LNG carriers or FSRUs or FPSOs. The 2 main technologies are called NO96 and Mark III. I will have a little description of these systems on the next slide. On this side, for shipping or FLNG units, we have relative success in this field. Around 70% of current LNG carriers are using our systems. The remaining is Moss, principally. And regarding hulls on order, LNG carrier or floating units, we are above 90%. The remaining is Moss containment system. We have one technology for onshore tanks called GST. It is an adaptation of Mark III technology to onshore constructions, to onshore tanks. We have also one technology for a subsea cryogenic pipeline for LNG called Pluto 2. Pluto meaning pipeline under the ocean. We are fulfilling international standards, and we are approved, of course, by major classification societies. In terms of containment systems, so I'm talking about membrane. Membrane is one typical design that you will find for LNG, to store LNG. We are here, membrane. We are called integrated tanks, so it means that we are directly fitted on the hull of the ship. We are not a self-standing tank or independent tank. We are an integrated tank directly fixed on the hull of the ship. And GTT is today the only provider of membrane systems, NO96 and Mark III, as I told you just before, which are the leading systems, and another one called CS1. If we look at membrane tanks, so this is an LNG carrier equipped with membrane systems, easy to recognize, flat deck, a trunk deck, the cargo room. And inside the tanks, you have this kind of shapes, prismatic shape, and the membrane shining inside the tank. This is a Mark III technology that you recognize relatively easily through the corrugations that you have on the primary membrane, which are here to compensate the thermal stresses that you have, or the ship bending motions, ship elongations linked to bending motions. And on the other side, here it is inside the NO96 tank. Materials are a little bit different. We are using Invar as membranes, and for insulation, we are using plywood boxes filled with perlite. On Mark III, the membrane is corrugated stainless steel membrane and a composite material for the secondary membrane, and insulation is made of reinforced polyurethane foam. We will see in the next slide that if we need to reinforce the containment system, we will play with these different elements, the plywood box or the foam, because the insulation is a load-bearing insulation, so we have to transfer the loads coming from the liquid, from the LNG, to the hull. So we have to carefully check that the strength of the containment system is able to withstand the slushing loads. Okay, some examples now. We have been on board the first and the only LNG RVs used for offshore operations. LNG RVs and RVs for XMAR Accelerate and HUG GDF Suez. There are regas plant with pioneering vessels, regas plant on the forepart of the ship, APL STL buoy for gas discharging and direct sending into the gas grid. At that time, slushing studies were made to look at the reinforcement that we needed for the containment systems. To provide some more flexibility in terms of gas discharge, there is a high pressure manifold here on the side of the vessels. And some calculations were made by GTT as well regarding the ship-to-ship transfer and in particular the flow rate for the ship-to-ship operations. So this has been the first offshore LNG application in the world. The first has been XMAR Accelerate. They have 8 vessels equipped with NO96 technology, classed by BV. They were approved for partial filling operation in the Gulf of Mexico and Massachusetts Bay. Since 2005, these vessels have already made this kind of operations. The projects, you may know them under Gulf Gateway or Northeast Gateway. These vessels were made for this project. Mark III has also an application for offshore LNG. These are called SRV, Shuttle and Regasification Vessel, for HUG and GDF Suez. These vessels have been classed by DNV and approved for offshore partial filling operation. Again, in Massachusetts Bay, this was a project called Neptune project. One point to notice is that one of these LNG RVs, 138, called Excellence, has performed full discharge operations during Hurricane Katrina in the US. So it was discharging at Gulf Gateway Terminal, and they have unloaded the complete cargo of the ship while Hurricane Katrina was nearby. We have also some projects and some experience in conversion. Membrane is not only used for new builds, but also for conversion. In particular, not so far from here, Lekas terminal in Malaysia, which is in fact the first regas terminal for this country, close to Sungai Udang area. 2 MISC vessels have been converted. So this is Tenaga Empat and Tenaga Satu, or FSU Lekas today. And they are moored at an island jetty. The terminal has been launched earlier this month, and first gas is planned for August now. And, of course, some orders on the other side, on floating unit, LNG FPSOs. There are 2 projects today, Shell FLNG. EPCI has been awarded to Technip Samsung Consortium for Prelude. Combination of LNG and LPG, and GTT systems will be, the tanks will be all selected for both LNG and LPG. So this is a huge storage capacity which will be made with membrane and Mark III containment system. Most recently, this is the second FID which has been taken. It is Petronas FLNG number 1. EPCIC awarded to Technip DSME really recently for canoid gas field. We know that it's a smaller project, 1.2 MTPA, but it is also using membrane storage tank NO96, this one. I will show you afterwards what I mean by 2-row membrane system. It is a special arrangement that we have for LNG FPSOs. We have orders, but we have also some other projects ongoing. These are only some public projects for which it is public that membrane has been selected. Accelerate, for example, they have already performed their generic design a few years ago. They are starting a specific project for North America, export terminal. They have selected 2-row GTT Mark III containment system, relatively large storage capacity, 250,000 cubic meter. HUG as well has selected membrane. Several projects are ongoing. 2-row GTT NO96 this time. And Total, we have been talking about Total, if they were looking at floating units or not. Yes, they are. And they have selected membrane as well. It's still open between NO96 and Mark III. We are working on some other projects, but this one are the only public ones. So this is just a summary. you find all the FLNG units here. And in terms of regas vessels, many orders of new build FSRUs since last year, all with membrane, and dispatched between DSME, Samsung, and Hyundai. There are six vessels on order as regas vessels. Okay, let's go more on technical sides now. We have several aspects to look at when designing an FLNG unit, which are linked to the containment system. First one is the famous sloshing issue. There are two principles to solve this one. One is to simply increase the strength of the containment system at such a level that we are able to withstand the sloshing loads. This is the first option. I have a barge design, I have a tank design. I just compute the sloshing loads and reinforce my containment system at the right level. Another solution is to reduce the sloshing loads. By doing that, I can change the ship motions, have a large draft, increase the roll period of the barge, or another option is to change the shape of the tank. And this was the beginning of the two-row arrangement. For each project, one point is that a dedicated sloshing study is made by GTT. Each project, there is a sloshing test campaign to assess the strength of the containment system. This is made in our laboratory, and we are screening all the aspects which have an influence on sloshing. The sea state, of course, the wave height, the wave period, this will have an influence on the sloshing behavior. The ship design, of course, the ship geometry, seakeeping characteristics, the shape of the tank, the position of the tank within the barge, this will have an influence as well. And the filling level, are we in head C, beam C? So these are all parameters which are screened during a test campaign at GTT. Here I have a video. So this is based on the ship motions. So we have 3 test rigs like that. The biggest one has a 6-ton payload, and currently we're performing our test at a scale 1 to 40. So of course there is a huge procedure to do that in terms of methodology, post-processing, pressure acquisition, and so on. So we are, of course, around most of the state-of-the-art in terms of sloshing tests. One point, we are using model tests to define our impact pressures. We're not using CFD. For CFD, CFD is not able to capture every specific phenomenon, every impact effect that you have on sloshing. And so today, CFD is not able to predict accurately impact pressures on the tank wall. So that's why we are performing model tests. And that's why we have 3 test rigs which are running all the year. They are fully automated. They are running 24 a day, 7 days a week, and all the year. So depending on the results that we have found from the test rig, after post-processing and so on, we may need to increase the strength of the containment system. GTT is always working on its technologies to improve them, to reinforce them. And one project, one development called Mark III Flex has been focusing on the strength increase of this containment system. If you remember, Mark III is based on reinforced polyurethane foam. We can simply increase the strength of this panel by putting more density, by increasing the density of this foam. By doing that, for example, we started from 130 kilogram per cubic meter to 210. By doing that, we have more than double the compressive strength of the foam, and as such, we are able to withstand much higher sloshing loads. This is a way to reinforce the containment system. For NO96, we have also the same type of reinforcement. Of course, here it is linked to the technology itself. NO96 is no more based on reinforced polyurethane foam, but on plywood boxes. Reinforcement is thus made on the plywood parts. We simply put thicker plates, thicker bulkhead, thicker covers to increase the strength of NO96 containment system. And so, if we need, depending on the sloshing pressures that we have found during the model test, we can use one type of reinforcement. So this is the first option, reinforcement. The second one is to change the shape of the tank. And this is what was mentioned as two-row arrangement just before. Shell Prelude FLNG, Petronas FLNG1, are featuring this specific arrangement for floating units, offshore units only. Here you have a standard cross-section of this kind of unit. Instead of the normally on a LNG carrier you have only one tank, a breadth of the ship, only one tank. Here we have two, one row and two row. This is the simple way to remind it. You have two adjacent tanks abreast of the ship, which are separated by a full cofferdam, which has two functions. The first one is to provide strength for topside module support here, so you will conduct the loads through the cofferdam, and to reduce the sloshing phenomena. It is, I would say, a normal practice in the shipping industry. When you want to cope with sloshing, you simply make smaller tanks. This is what we do here. We have split the tank into two smaller tanks, and by doing that, we are reducing the sloshing phenomenon because we separate ship motions, so excitations, and the liquid natural frequencies. We simply separate these two characteristics. We have tested several geometries, several capacities for many clients, ship owners, shipyards, and so on. With this kind of arrangement, we have always concluded to full operability on site. So it means no restrictions in terms of filling level, or in terms of filling level or wave height, and so on. Full operability for Australia, India, Africa, South America, and so on. So I have again a few videos, 3 this time. Yeah. So this is a normal shape, just a little representation of one tank of a two-row arrangement, and the color is just giving you the sloshing intensity as a function of the filling level. What we see that this range is the leading one, the one on which we will focus because it is the one leading to the highest pressures. We have this kind. So these are tests which have been made at GTT for one project. We are in pure BMC, 5 meter HS at the critical wave period. So this is the worst that was expected. And you see we have this kind of wave, traveling wave from one side to the other one of the tank, which is in fact not inducing a lot of pressures because we have a narrow tank. If we go up here, same conditions, still pure BMCs, 5 meter HS, and again, few impacts on the top, but not really critical again because of the breadth, and we're at high fillings. And something very funny, in the middle, in this range, we have this. If you notice, a different wave behavior. Here we don't have this wave traveling from one side to the other one. We have what we call a standing wave. The wave is just licking the wall. It is something which is not critical at all, and if you look carefully, we don't have any impact of liquid in the tank. Simply, we don't have sufficient energy in the system. We're still in pure BMC. We are at 8 meter HS this time. We don't have sufficient energy in the system to be able to induce impact loads. So when we perform our sloshing test campaign, we are going through all these filling levels, and we are able to define this kind of map, which are given to the operator or ship owner. And so we are able to look at what is a good situation, is it safe, is not, or not. And these three pictures here showed you this is same color scale, same y-axis, same x-axis. This gives you the sloshing intensity as a function of the wave height here and wave period. This is head C, quartering C, and beam C. And what you see, exactly the same scales on the three plots. What we can notice that beam C remain the most critical situation, simply because we keep a given ratio. When we make the tank design, we have a given ratio between the length and the breadth of the tank, which make that longitudinal waves cannot occur. As you can see, here we still have the worst conditions, while in HC we have nothing critical. So when we do the tank design, when we are arranging the tanks, we keep a given ratio to be sure that the worst remains beam C, which is in fact the less probable situation for an LNG FPSO. Okay, this was about sloshing. Now we have other options linked to cargo handling. Cargo handling is just a matter of design. I would say we can do everything you want. You just have to define what you wish. For the pump tower, one main question is removable pumps or not. On LNG carriers, you have fixed pumps. So you have this kind of structure inside the tank. This is the pump tower, and pumps, you have one and there, which are fixed. Which means that when you need to make the maintenance of the tanks, of the pumps, sorry, you need to open the tank, decommission the tank, open the tank, and remove the pumps. For an LNG FPSO, one option is to use removable pumps. It means that even if the tank is filled with LNG, this is something which is done for, in fact, for onshore tanks. Even with the tank filled with LNG, you are able to remove the pumps directly, so you don't need to decommission the tank and so on. So we have adapted this structure, this pump tower, to be able to accept removable pumps. And so you don't need to decommission the tank to maintain the pumps. Some other design options, these are really options. It's really linked to the operating philosophy of the crew. Regarding filling, all LNG carriers are normally filled from the bottom, so you have a bottom line. As an option is the top filling. This could be used for recirculation of LNG if you detect stratification to avoid rollover or things like that. So you can use top filling, which is not normally done on LNG carrier, so it is an option for floating units. To discharge the pumps, to offload, questions to ask are number of main cargo pumps, 2, 3, this is linked to the capacity that you wish. Do you need a stripping pump? And the question I mentioned just before, fixed or removable pumps. These questions will have an impact on the design. Everything can be done, just we need to think about this when writing the specification of the unit. Another point is the number of simultaneous operations you need. Production, offloading, maintenance, all this will impact your piping. Nothing impossible again to do. This is just the right question to ask, because we may need additional lines to fully segregate the tanks and to allow the maintenance of one tank regularly. By class, we have to maintain the tank regularly, so we may need additional line for that. Cargo tank operations. In addition to the standard package that you have with membrane, standard package is that membrane is not sensitive to thermal shocks. So we don't need a continuous spraying, and we have the fastest commissioning and decommissioning time. Membrane is not sensitive to thermal shock. We can have very fast warming up and cooling down. And standard package is linked to the protection systems. Tank and insulation space pressure control against vacuum and overpressure, of course. A water detection system if you have water coming inside the insulation system. Something very important, and one of the main assets of GTT membrane system is a continuous tightness monitoring system. Here you have a view of a cross-section, simplified. You have the hull, the two insulation spaces, and LNG. These two insulation spaces are constantly inerted with nitrogen. So if you have a defect one day on a membrane, you will have gas concentration which will increase in this space. And this gas content is analyzed every 30 minutes, and we're able to detect if membrane is tight or not. So every 30 minutes, you don't need to inspect the primary membrane. It is automatic. Every 30 minutes, you know the gas concentration, the methane content inside your spaces, so you know if everything is tight or not. So this is, and you have also temperature sensors. This is a standard package. One option is regarding a density meter, and in fact a level temperature at density transmitter. This is one option. If you think that you can have rollover phenomenon or stratification on your FLNG unit, you can consider to implement this LTD transmitter. Okay. A few words about construction now. Typical hull construction sequence of a membrane design is first to start with prefabrication in workshop of containment system elements. It is automated. You see some prefabricated panels of Mark III, starting the prefabrication of a NO96 box. This is automated. There is quality assurance, quality control procedures. And then when it is prefabricated, everything is shipped to the yard for integration on board. In the yard, you have several steps. First is the block assembly in dry dock. And during block assembly in dry dock, you install, so this is in a yard, you install in parallel a dedicated scaffolding to give you an access and to be able to build the tank inside the hull. And you keep a little access, a side shell opening, to just give an access inside the tank when the ship will be launched, and the hull completely closed. When the hull is finished, you can go to outfitting K and start the containment system erection. So this is the standard way, which makes that tanks are not on the critical path. You are still able to modify, even lately, the hull and tank dimensions, because membrane, it's small elements, as you can see. It's a small box, it's a small panel, 1 meter by 3 meters, for example. So you are still able to adjust the containment system elements to cope with late modification of the hull and so the tank. So we do not start tank construction before the hull construction. This is a major point. We still have room to modify a little bit when you're implementing such big projects, to have some room to modify a little bit the hull, linked to the top side sometimes. You need to adjust a little bit the hull. One point is on the pump tower. So once you have installed the containment system inside the tank, you need to install the pump tower. Here you have different approaches depending on your master schedule. If the long lead item is a topside engineering and fabrication, you have simply no impact on the hull. You follow the standard procedure: block assembly, containment system, pump tower, and then topside. It's logical because long lead item is the top side. If not, you can keep a free space on top of the liquid dome in the hull to be able to insert the pump tower. The pump tower is inserted in one piece through the top of the tank and inserted and put in place. By keeping a free space, you can still work. You can build the tank, CCS installation, in parallel with topside installation. Or if you cannot keep a free space, if you want to, you can still work in parallel on the containment system and the topside by changing the location of the pump tower. This is another option. So the point to, just to remind is, we can work, tanks are not on the critical path, we can work on the topside and in parallel in the tanks. But a procedure is nothing if we don't have a yard. GTT is licensing shipbuilding yards. Today, we have 23 licensed shipyards, mostly in Asia. Some have some yards, like DSME and Samsung, have a record: 15 membrane vessels delivered in a year, each. So all yards which have been used to build LNG carriers are qualified workforce. They provide you slot availability, and they don't need to invest on new infrastructure. They already have the tools, they have already trained the workers, they have already the scaffoldings, and so on. And they are quite efficient because they have optimized all the production schedule, and they need, for an LNG carrier, between 15 and 18 months only between steel cutting and delivery. So it's a relatively optimized construction and production schedule. For an LNG carrier with membrane, the asset is that we do not spend a lot of time in dry dock, typically 70 days for an LNG carrier. Important is that we have several shipyards, which from GTT they receive exactly the same services. This is the normal practice. We have numerous shipyards, several approved suppliers. This makes that there will be significant procurement saving. There is not only one supplier. And the same shipyard is controlling both hull and containment system. Is building everything, hull and containment system. So there is no risk of delay in terms of schedule because he's mastering the complete production chain. And there is no requirement for complicated logistic chain where you need to integrate several elements coming from several suppliers. This has been recognized by some people. For example, Shell paper. In Shell paper at Gastech last year, where they are mentioning that they have chosen membrane for their cost and schedule advantage compared to the others. Technip as well, in one recent paper, Technip, which is important that they have been involved in many feeds with membrane or with other containment systems, and they have been able to compare. And they confirm that we have advantages in terms of cost and schedules. And finally, Total, in their brochures, mention an important point, which is the experience linked to membrane and the precautions are taken to mitigate slushing. It is the two arrangement I have shown just before. Okay, and last point. Total was mentioning about experience. This is a little table summarizing the experience of the containment system that are offered today for floating LNG carrier or floating units. So this is membrane, of course. We have delivered around 260 hulls today, LNG carrier or FSRUs altogether. We are around 75 hulls on order, on the order book currently. All those vessels in service, 43-year-old, soft-com float vessels, initially designed for 20 years, but still sailing today. Of course, we have the largest experience compared to all the others. In terms of FSRU or FSU, operating at K, there are 4 vessels in service, 6 on orders. We have seen the table before. 10 offshore regas capabilities or the RVs for Exmar, Accelerate, and HUG, and the 2 orders for LNG FPSOs. Moss is the second one, which has the largest experience with 110 hulls delivered today. Quite old vessels as well, 39 years, but a little bit less experience in terms of offshore. And the last one, SPB, which has delivered 2 ships 18 years ago. We were talking about experience. Total was mentioning experience. This is used for design and maintenance. When we look at the size of membrane tanks that we are using, that we have already built with GTT, we go from very low. This is a very small tank, around 6,000 cubic meter, to very large. This is a QMAX tank, 50,000 cubic meter. We have been able to do that, but based on the experience for membrane LNG FPSO, we are within this experience. We are around 25 or 35,000 cubic meters. So we have smaller tanks for LNG FPSOs. We do not extrapolate from the experience to something bigger, to something that we have not done. We keep our tank sizes within the experience of our LNG carriers. So we know that in terms of construction and so on, it is possible, largely possible to do, and we do not have any construction or design issues. Our ships equipped with our membrane system are sailing all around the world. They have seen many things. The first vessels I mentioned, which are 43-year-old, have been made a trip between Alaska and Japan during 20 years. Many transatlantic routes. One Q vessel even went through Cape Horn. Some hurricanes as well, Katrina, for example, in partial filling, but some other hurricanes. And one severe grounding, even we know that membranes remain tight even in case of severe deformation of the hull. A long time ago, one ship, the El Paso Paul Kaiser, went a little bit too fast in the ground, in rocks, and on all the tank lengths, all the ship lengths, you had big deformations. And membrane has shown its robustness as it remained fully tight. No loss of LNG, nothing. And we have, of course, many LNG qualities which have been experienced by our membranes as we are loading all over the world. So we are taking all this experience for the design and maintenance of our future hulls. Especially for maintenance, all the experience is gathered by one department of GTT, which is the operations department. Today there are around 40. They are here in the yards, shipbuilding yards or ship repair yards, to help during construction and survey of the tanks. We have special agreements for that with ship owners. This is when we are out of the guarantee of the ship. We have special agreements for ship owners and yards to assist them. And we have today around half of the fleet, half of the membrane fleet is covered by these contracts. So we are regularly called by ship owners or ship repair yards for our advisory services to check what is the current state of the tanks, what should we do, and so on. This is a little table, a little graph showing in blue the number of delivery per year. This is for all the years before 2002. And the number of dry dock that we have attended. So this last year we have around 40 dry dock. We are attending around 40 dry dock and so tank survey. So we keep all archives and records of all these vessels, and this allows us to continuously improve construction, inspection, and maintenance procedures. Vessels, we have old vessels, 43-year-old. We have big vessels, small vessels. So we're mastering all the chain today linked to the number of vessels and their age. And so in particular for inspection and maintenance, something which is a little bit different compared to normal LNG shipping is that you do not go to dry dock to make the maintenance of the tank. You have to perform maintenance inspection on site. So we have solutions for already many years to control primary and secondary barriers while the tank is in operation. So for the primary barrier, it is relatively easy. It is a standard continuous gas concentration measurement system. Every 30 minutes, we know the tightness of the primary membrane. And for the secondary barrier, we have a test which is running for many months now, which is called a thermographic assessment of membrane integrity. This test allows to check the secondary barrier while the tank is filled with LNG. So this is really important. We don't need to decommission the tank to check that. Inner hull control, cargo hold side not exposed to the side of the plates on the cargo hold part are not exposed to external aggression such as light, oxygen, or humidity. So this part is relatively is clean and don't need to be inspected. And the face of the inner hull, so in fact, in all these areas, when you are on the double walls, double bottom, double deck, this face can be inspected even if the tank is filled with LNG. Of course, the ballast tanks have to be empty, but we can check the inner hull of the barge even if the tank is filled with LNG. Existing procedures, inspection and repair procedures, are all applicable on site. For repairs of membrane and insulation, we can perform that on site. We can repair the inner hull on site, even if the containment system is in place. We can weld on the inner hull, even if the containment system is in place. We have already done it. It's just to take the sentence of René, nothing big, we have done it. And if we need to have an access on the upper part of the tank, we have an offshore scaffolding. The design has been completed and can be used if necessary. And one advantage of the two-row arrangement that I mention only now because it is linked to maintenance is linked to the number of tanks that you have. You have 6, 8 tanks to store the LNG. And as such, when you decommission a tank for the routine inspection, the volume that you lose, because the tank is decommissioned, is relatively small. So this gives you more flexibility in your operations, because you still need to offload, to produce, and so on. So this is one of the advantage of the two-row arrangement, that we have smaller tanks, so a better flexibility during maintenance. If I conclude, membranes are considered for many projects, FSRUs or FLNGs. Many owners consider that risks are mitigated by using a proven and experienced technology. You have seen some statistics. We're an engineering company. We're able to adapt our system to meet production constraints. We have a design for oil filling applications, reinforcement or two-row arrangement. Cargo handling system can be very flexible depending on what you wish to do. Maintenance and inspection, all performance side. And finally, it has been also recognized by several entities that we have some cost and schedule advantages with units using our systems. Thank you.
Thank you very much, Stephane, for a thorough presentation again on the tank system. If you have nearly 100% market share, either there's something wrong with the market, or you must have a superb product.
I choose option 2.
Questions for Stephane?
Thank you very much, Stephane. You talked about the ability to inspect the two-row tanks.
Yeah.
Did you say that you can inspect one tank while LNG is in the adjacent tank?
Yes. So you can inspect, even if all adjacent tanks are filled with LNG, you can also inspect a tank. You have to, in fact, you have a cofferdam bulkhead between two tanks, and the tanks which are filled with LNG, the insulation spaces are still under nitrogen atmosphere. So you have several separations between the LNG of the adjacent tank and the tank you are inspecting. So you can do a lot of things inside this tank because it is fully segregated, and you have several levels of segregation between the tank you are inspecting and the other one.
I still would be nervous.
And you can weld. We have already made some welding in a tank while the other one was filled with LNG.
I have two questions. First one is a simple one. Do you have any licensed shipyard in China?
Yes, we have. In total, we have 7 yards licensed in China. Only one today has experience of LNG carrier shipbuilding. It is Udong Zonghua, which will be delivering the number 6 very soon, if not yet done. I think the sea trials have been made, and so normally it will be delivered very soon. Udong Zonghua has also 4 other ships on order. We have other yards such as Rongsheng, Dalian, SWS, which are licensed as well, but for the moment they have not received any order.
Second one is that you have NO96 and Mark III. Mm-hmm. Is there one better than the other? And why do you choose one and not the other one?
So, Mr. Moon from DSME will explain you that NO96 is the best one. No, so from our side, so just for historical reason, we have both NO96 and Mark III. Before GTT, it was Gas Transport and Technigas. So it was Gas Transport, one French company, Technigas, another French company. One developed NO family, NO82, NO85, and so on. And the other one, Technigas, developed the Mark family, Mark I, Mark III. This was competition between the two French companies, but in 1994 they merged. And at that time, so you have to remember also that a yard is selecting one technology. Even if they are licensed for all the technologies, one yard is specializing in one because the tools are not the same, the production principle is not the same. So DSME is specialized in NO96, Samsung is specialized with Mark III, for example. And so when we merged, when the two companies have merged, we have yards with NO96, Tomovers with Mark III. So we could not abandon one yard. So we kept the two systems in the portfolio of GTT. And because of that, we have to maintain, because we should not advantage a yard compared to another one, we have to maintain all the systems at the same level in terms of performance and cost as well. It is, we have no choice. We have committed to that.
Does it mean that if you go to Samsung, you only do Mark III?
Yeah.
And you go to Daewoo, you get...
You will have NO96.
Any other questions?
Yeah, can I just ask a question related to that? Because I thought you made a remark for one of the companies that they were still deciding between the two systems. They hadn't decided yet. Does it mean that depending on the choice, that implicitly means they then decide for which yard?
No, normally you keep open the membrane, the choice, unless you have really a technical preference. Normally you let open just to play with the cost competition, the standard cost competition that you will have between the yards. So normally you just specify membrane. DSME will have a solution with NO96, Samsung will have a solution with Mark III, Hyundai will have a solution with Mark III, STX with NO96, and so on. And then you select the best solution. Or for those who have chosen, they're a little bit more advanced, so it's Accelerate and HUG. They're a little bit more advanced than Total, which is still open. HUG and Accelerate have already made a feed. And so they've already selected a yard. So this is the reason why you have Accelerate and HUG, which are associated to a containment system, while Total is not.
Any other questions? I see the usual gentleman not putting his hand up. I'm safe. Thanks a lot, Stephane. Thank you.
Thank you.
Thanks very much, Stephane.